Robin, co-founder of Abstracts. There is my other co-founder. We've been building Abstract for like a year and a half now. And we are really excited to show you why we're building it, and how we built it, and how you can get started with it. So what is the Abstract platform? The Abstract platform consists of three major components. There is the on-chain infrastructure, which we call the SDK. It's a set of smart contracts that we deploy, and they allow you to collaborate. They allow you to create smart contracts that can be used. The other part of our platform is our dev tooling, CW Orchestrator. You might have heard of it. We built it because we really needed it, and we think the space needs it, because it allows you to test, deploy, and share your smart contracts very easily. And then the third component is the front-end library. So this is an account abstraction toolbox for your front-end, so you can plug into our on-chain infrastructure very easily. We have a workshop there in AwesomWasm on our dev tooling specifically, so be sure to join that to see how you can speed up your testing game. And then, why did we build this platform? Because we want to simplify smart contract development. It's really hard to write smart contracts. So, as an example, we're going to be talking about an auto-compiling application. And we chose this application as an example because it really showcases how most of the applications that we write can be split into functional components. So, we're going to be doing that with this auto-compiler. First, I'm going to walk you through what it's supposed to do. So it has three major functions. The first is to deposit, so a user can send tokens to the auto-compiler. The auto-compiler will then put those tokens in an LP pool, and then use those LP tokens to stake at for the specific DEX and start earning rewards, right? Yield farming. So that's the deposit. The compound action, auto-compiler should recurringly call claim the rewards that they're earning on their LP tokens, and then sell those rewards and LP them to increase the stake. And then to withdraw, the user should be able to send their shares back to the auto-compiler, and the auto-compiler should withdraw the liquidity and send it to the user, depending on how many shares they gave. So how would we implement this, right? So we need to interact with an exchange. That's very clear. What are some of the knowledge requirements for that? Message structure. How do we swap? How do we provide liquidity to this exchange specifically? What are the addresses of the pools that we're trying to use and the staking contract? Is there a lockup period to the staking? And is there any fee structure that we need to incorporate into what we're doing? And these are very complex questions that you as a smart contracts developer need to take into account before you even start implementing it. Right? It introduces a lot of complexity to your application. So let's say that we're actually doing this. What you would do is you go to source code of the project, you try to understand what they're doing, which might not be very clear. You import their packages, and then you write calls in your smart contract to their smart contract. And then you try to test it. And testing is really, really hard. So as a result, you have a lot of code in your code base that you need to maintain that's not actually yours. And every project does this from scratch. Everyone who has worked with Astroport or Osmosis, whatever, they have gone through this process. And it's a waste of our time. So what we at Abstract realized that we can actually separate the auto-compiler implementation from these integrations. And this allows us to only care about the business logic, which is the actual auto-compiler implementation, and then outsource all the grunt work of interacting with the exchange to another contract. And the beauty here is that this outsourcing benefits everyone. Everyone can start using this exchange thing to interact with exchanges and with any exchange. Right? So it fosters collaboration. Now, we start with better wallet. So every abstract application is built on top of a smart contract wallet, and this wallet holds funds and it executes accounts that are sent to it. So it acts as a proxy for message execution. And we made it modular. So we added the ability to install a module, so a different smart contract on top of the smart contract wallet, which makes the wallet extensible. And it gives the smart contract wallet superpowers because this module is able to construct messages and then forward them to the smart contract wallet, which then executes them. So we can start programming logic around the smart contract wallet. And what does that practically look like? Okay. We have our DEX module, and our DEX module, as previously mentioned, is allowed to execute messages on the smart contract wallet. And it does one thing: it interacts with DEXs. So it exposes standard API for anyone to call to do a certain action on a specific DEX. So there's a snippet right here. In this case, we're only showing the swap. So if I want to do a swap on a smart contract on an exchange, I would provide the offer assets, so the funds that I'm trying to get rid of, and then the ask assets, the assets that I want, and then some information to assert that my slippage is within my bounds. So then, if I'm the owner of this smart contract wallet, I can fund my wallet and then send a very simple message that is human readable to my DEX module that will then perform a swap. So here's an example: DEX action, swapping on osmosis. We are providing the action, so I want to do a swap, US dollars to euros, and anything like spread. So what happens then is the DEX module takes in that information as, oh, this person wants to swap on osmosis, cool. Then they will need this specific message of information that is not human readable, that we don't even need to interact with, we don't even need to know what's going on. And this will send it to the smart contract for execution, and then the smart contract wallet will execute that, and we will swap their funds. And this is modular. So instead of the owner of the smart contract wallet calling the DEX module, we can have another smart contract on top that calls it and does the swaps. So we have other integrations as well. So Truncat module, this allows you to set up run jobs, so recurring transactions that are now easily programmable through abstract. You can interact with Wind, Osmosis, Astroport. You can do swaps as well as the staking and rewards that I mentioned earlier. So you can start hacking with this. And then there are applications that we've built on top. So an example of which is the DCA application, dollar cost averaging. What this does is it sets up a cron job to recurring call a swap action on our DEX module. And this can be done with very minimal logic because we just forward the calls to the specific module, and they then parse the actual integration logic and the business logic. Some other examples are the ETF module. So this allows you to create an ETF, and then people can deposit into the ETF. And then there's a basket of assets that can be managed by some trader, owner of the account. And then people can invest into it, or other shares. Subscription module allows you to create a subscription on-chain, and there is an unsubscribe hook that gets called whenever someone stops paying their subscription. So you can set up a service on-chain that requires someone to pay for it, and if they stop paying, you can block their service. Now we have some other modules. So back to business. We were building this autocompiler module, this autocompiler application. So if we now think of our application as functional components, we can construct an architecture that uses the different modules to achieve the functionality that we want. So in this case, we have an autocompiler module that depends on the DEX module for swapping, providing liquidity, withdrawing liquidity. We have a staking module for claiming the rewards, staking and bonding. We have a Croncat module that handles the recurring calls to contracts. So we have our cron jobs. And the nice thing is that we have explicit dependencies in our smart contracts that ensure that this auto-compounder module cannot be installed on our smart contract wallet unless the different modules are installed and their version requirements are met. So this is basically like importing a package in your cargo with Automo. You're saying, hey, I want this package with this version, and you can even have like more complex version requirements that you're used to, but now it's in smart contracts. So you're taking on dependencies on smart contracts, and this really allows you to build crazy stuff. At least that's what we think. And now users have the ability to deposit their funds and earn rewards on them. And now shout out to 32 because they've actually built this. This is something that we're working on with time. And this allows us to create a comparison. So Spectrum Finance is an auto-compounder that was deployed to the Terra network. 42 is the abstract-enabled version of it. And you can see that there's a great reduction in the amount of code that they needed to write because of the separation concerns. They had to only write 2 smart contracts. They were able to do it much faster, and it's much more integration friendly because of the modular architecture. Someone could take on a dependency on this auto-compounder module and then build an auto-compounder aggregator. And do crazy strategies between the different auto-compounder faults to even go further than this. And there is effortless upgradability because this DEX module, when there's new support for DEX, the only thing we need to do is migrate the contract to a new version, and there are no breaking changes on the auto-compounder side. It's just a configuration of the side. Excited yet? So, little sneak peek into building an abstract. We actually had a workshop earlier today, so if you missed it, I think it's recorded. There is a public repository. If you go to GitHub/abstract SDK, there's a workshop repository right there with a README that will guide you through getting started with abstract. But this is some code form about defining a module. So we have the $costs average module right there. There's a type that we declare, and besides the point, here's a module ID. So this is a unique identifier that we associate with this specific smart contract, and then a specific version. And this is what is used in our package manager to figure out whether our dependencies are met. And then here we set the actual dependencies. So we have our Croncat ID and the version that we want to be compatible with, and the same for the DEX adapter ID and the version for that. One thing to notice is that this is a constant. So this is like heavily optimized by the compiler, so there's barely any runtime overhead by doing this kind of stuff. So briefly mentioned the package manager. NPM has proven that package managers are really good for adoption, and we need to start using dependencies in our smart contract if we really want to get anywhere. Right? We're all building stuff from scratch. That's not how we write software. And then it also allows for smart contract code distribution. So when you depend on a module, you can install it on your account, and there can be a monetization that is related to that. So maybe if you use someone's code, they're putting time into that and maintaining it. They might ask for an installation fee, subscription fee, so that they can keep maintaining their code, which is something we also really need in this space. And this way of creating applications also switches the way that upgradability works. So right now, you send your funds to some application. Those developers choose when they migrate their contracts and to what code they migrate it to, right? And that's really not very trustless. So in this case, when you depend on a module, you have the ability to migrate it whenever you want. which is really, really important for us. And here's a little bit about implementing the module. So within your implementation, so your execute functions, your instantiate functions, you have access to your app, the app struct or object, and we have API constructors. These are trait-based functions that you can call on your app to create APIs to the modules that you have that you're dependent on. So right now, we can then use that API, so in this case, text API, to create a swap call to our API with one line of code. And this is text, this is generic, so you can use osmosis, but you can use AstroPort, you can use whatever. And this really allows for very, very complex code to be written in just one function call, right? And to use these smart contracts. So it really allows for more complex applications to be built on top of AwesomWasm, which is what we really need. So I'm running a bit fast, apparently. If you want to learn more, we have documentation and docs at abstract.money. You can join our Discord, ask questions. If you're interested in building an application on Abstract, reach out to us, and we would love to help you get set up with Abstract, with tooling, and just help you in the process of building out your application. Are there any questions? What's the question? Okay. So it's a question about CW Orchestrator. The way that we have set up our infrastructure is we create a top-level package. It's called abstract interfaces. And this contains interfaces to all our smart contracts. So an interface is basically a wrapper around the smart contract that is environment generic. So you know how you can deploy a smart contract to CW multitest. You can do it to a local chain. You can do it to testnet, mainnet. All of these environments, most of the time currently, people rewrite their code to do it for each environment independently. What we try to do is create an interface for your smart contract and then allow you to drop in the execution environment that you're using. So instead of writing specific code to deploy to testnet, I write generic code that interacts with my contract interface. And then I just insert whatever execution environment that I want to use. So that could be multitest or local chain, whatever. So then we took it a step further. Right now we have these environment generic interfaces. What if we bundle them so that we have all of the abstract infrastructure? And what if we then, when we publish it, we both add the WASMs to the crates and also add our deployment addresses. Right? So now this whole package of contract interfaces, WASMs, addresses is shipped into one crate, and I can ship that to all the developers that are using Abstract. They can import it, and then they can load Abstract from all the chains that we're deployed to without having to go and figure out what the addresses are. And they can deploy it to a local chain. They can even deploy it to testnet mainnet if they want, and they can spin it up in CW multitest as well. So we just ship complete code base to the user, and they have one line of code that they can use to start interacting with it. So that's the power of our tooling, and I think every AwesomWasm application should start using CW Orchestrator because it just allows frictionless collaboration. I think that's really, really needed. We need to start collaborating more.